Hello everyone, I want to show you how to undertake a binary logistic regression in Minitab, and a great way of doing this is to show you how we could undertake this using the Titanic dataset, which we've been using quite a lot on the module. Just recall, the dataset shows me the names of all the people that were on the Titanic, the class they were travelling, whether they survived the sinking of the Titanic or not, their gender, their age in years, whether they were carrying siblings, taking siblings or spouses with them, whether they had parents or children with them, and some other information as well, which is not relevant to this analysis. So what I'm interested in here is I want to know if age, sex, and passenger class are good predictors for whether people survived the sinking of the Titanic or not. Think of women and children first. Did that work on the Titanic? Was the chances of surviving better if you were younger and female? Maybe if you were in first class, is there a better chance of survival if you were in first class compared to if you were travelling third class? So what we can do is we can use the binary logistic regression to produce a survival probability for every single passenger, and then we can have a look at those survival probabilities. The regression will also tell me if age, sex, and passenger class are significant predictors of survival or not. So in order to do this, I need to go to regression, and I need to do a binary logistic regression. I want to fit a binary logistic model, and I'm putting as the response survived. That's a binary outcome, and the event that I'm interested in is survival is 1. In other words, survival, yes, they did survive. Survival 0 means no, they didn't survive. So that's my response event. Setting that response event is very important. What's the event we're interested in? It's the chances of survival that I'm interested in. My continuous predictors is simply age in years, but I've got 2 categorical predictors as well. Passenger class, which has 3 levels, first, second, third, and I've also got sex, 2 levels, male and female. There are my 2 categorical predictors. What I also want Minitab to do for me is I want to store the fits. Just like we might store the fits in a normal bivariate linear regression, here I'm storing the fits, which are in fact the event probabilities. What that will give me is for every single passenger, the probability of their survival using sex, class, and age as predictors of their survival. So I click, I want to store the event probabilities. I can also see, if I go into coding here, we can set. Remember, in a binary logistic regression, or in any logistic regression, we then get an odds ratio, which comes out. This is the odds of survival for every incremental increase in a continuous predictor. Now, our single continuous predictor here is age in years. So we can then say, well, what increment of age increase are we interested in for the odds ratio? Do we want every 1 year increase? The odds of survival, do they then increase with every year increase with age, or do the odds of survival decrease compared to the odds of dying with every year increase? I could set this to 5-year increments, 10-year increments, 20-year increments, and if there is something significant going on here, then the odds ratio will get larger, we would imagine, as the increment increases. For here, it makes sense to keep the odds ratio incremental increase at 1 year. Okay, so I click OK. I did store my fits. Yes, I did. So I can click OK again, and we get a rather long, scary output. Look, here's the fits, all arrived here. So I can see that, get rid of that, I can see that I've now got the probabilities of all of these people surviving using age, sex, and class as a predictor. As I scroll down here, I've then got my deviance table, which is a bit like the ANOVA table in a regression. This is saying, is the overall regression model significant? This is the regression, the binary logistic regression model, which uses age, passenger class, and sex as 3 separate terms in the regression model to then be predictors of survival, we can see that overall regression model here in this top line is highly significant. P is less than 0.001. I can see that age is a highly significant term in that regression. I can see that passenger class is a highly significant term, and sex is a highly significant term as well. Down here we've got the deviance r squared, which is the binary logistic regression equivalent of a good old r squared in a normal bivariate linear regression or a ANOVA, for example. It's not calculated the same way, but it can sort of mean the same thing. And I've got 30.55% of the variability in the probabilities of survival, which is explained by these three factors. Maybe if I want to raise my r squared, I need to perhaps put more terms into the model, or maybe I need some interaction terms going in there. I need perhaps passenger class times sex. Maybe I need to put some polynomial terms, passenger class squared, sex squared in there, for example, but that's complicating things. For now, I can see I've got a reasonable model with three highly significant terms. I could try and explain the better data. I can try and explain the data better, sorry. Here's my odds ratio then for the continuous predictor of age. This is showing me then that for every year increase in age, the chances of survival compared to dying decrease. And the odds ratio is a fairly small incremental decrease with every year increment, but look, that confidence interval about the odds ratio does not include 1. So this tells me that it's a significant effect. If I'd increased my increments and said maybe for every 5 years increase in age, what's the odds ratio of surviving? That odds ratio would plummet, and those confidence intervals would plummet around it as well, because simply the incremental increase in years for every unit of the odds ratio would have gone up. And then I've got then the odds ratios of surviving with passenger class. What's interesting here then is to have a bit of a play with these fits here, because I can make a rather beautiful graph. If I produce a scatter plot now of the fits plotted against the age in years, but I then colour different lines for gender and for passenger class, we see something that's really rather beautiful in a sad kind of way, bearing in mind where this data came from. So I would need to put the fits on the y-axis. These are the probabilities of every person surviving, those probabilities based on their sex, age and their class. So I need to put a quantitative continuous variable on the x. So the only predictor that I've got that's quantitative and continuous is age. So put that there. But my two categorical variables, in other words, I want to produce lots of lines of age versus fits, but for different classes of passenger and for different sex of passenger. So male first class, female first class, male second class, female second class, etc. Minitab's having a big think, because this is a big ask of Minitab, this, and I get this graph here, which I think is just incredible. What we can see then is the decreasing probabilities of survival with increasing age. So what I can see here then, these are the fits. If I have a probability of 1, that means that the passengers survive. So nobody has a probability of 1. They were definitely going to survive every time. But this group of people here that were young, female and first class, their probability of surviving the sinking of the Titanic was pretty close to 1. We can see we've got a fit of 0.969. So these probabilities are based on the data as a whole, a mathematical relationship of this binary outcome of 1 for surviving, 0 for not surviving, and looking at how that is dispersed among the categories of age, class and sex. We can see then we can produce these retrospective probabilities. For first class females, this blue line along here, we can see the probability of surviving decreases with increasing age, but the gradient is quite shallow. We can then see for second class females, then their overall probability of very young second class females surviving is not quite as good as first class females, and the gradient, the decline of their probability of surviving is much sharper, but they're still way above the probability of a third class female surviving, where we've got quite a steep gradient. Though interestingly, a very, very similar gradient, almost parallel line to the probability of first class males surviving. So it would have been better to have been a third class female. The probability of you surviving was ever so slightly higher than being a first class male. With age increasing, the probabilities of surviving dropped quite sharply, with quite a steep gradient. Women and children first seem to work quite well on the Titanic based on this plot here. For the second class males then, even for young second class males, the probability of surviving was less than 50-50, as we can see here, and then it declines sharply and downwards. And we've got about a 20% survival of even the youngest of third class males surviving. Their probability just declines. So a very a senior third class gentleman, the probability of those poor chaps surviving the sinking of the Titanic was very, very low indeed.